All right, we're factoring this one, x cubed minus 4x squared plus x minus 4 by grouping. In order to do this, you have to have it in standard form, decreasing order of exponents. Now, split it down the middle, okay? From the left, we can factor out a monomial. We can factor out an x squared, and I get x minus 4. Here, there's nothing to factor, so it's basically plus x minus 4, okay? Now you notice that you have a common term, x minus 4, x minus 4, okay? Now let's look at the coefficients of these common terms. The coefficient of this one is x squared. What's the coefficient of this one? 1. Now what I'm going to do is I'm going to write the common term off on the side, x minus 4, okay? So mentally just cross that out. Mentally just cross that out. Now, in another parenthesis, write down the coefficients of the common terms. So x squared plus 1, okay? And now I've factored the green cubic term, okay? The cubic expression. From before, I carry down what I had, so x plus 3 and x plus 2. These are the ones up here. And what I have here is x plus 2, x plus 3, x minus 4, and x squared plus 1. Can x squared... Right, so basically, technically what we did is we factored out an x minus 4, all right? That's what grouping is. You just write it once, and then you write down what's left, x squared plus 1. Now, can we factor the x squared plus 1? It's a quadratic. X squared plus 1 doesn't factor. We could have factored x squared minus 1 into x minus 1, x plus 1, but x squared plus 1 doesn't factor. Okay? Now, this is a quadratic term which does not factor. It's called an irreducible because it cannot be reduced. It's an irreducible quadratic factor. Okay? So, x squared plus 1 is a factor of our equation. It's quadratic, and it can't be factored. Putting it all together, it's an irreducible quadratic factor. It's a mouthful. And if you go back to the instructions, you realize that what we had to do was write kx as the product of linear and irreducible quadratic factors, and that's what we've done. Okay, so here we have linear factors and an irreducible quadratic factor.
So they're the same thing? The linear and quadratic?
They're the same thing in the fact that they're factors, all right? But one is quadratic, the other is linear.
So you just, that
right.
was your answer.
This is our answer. So basically, this is as factored as it could be right now, okay? Now, next it says, write the product, write kx as a product of linear factors, okay? So I can't have x squared plus 1 anymore because that's a quadratic. All right, now, we said we couldn't factor x squared plus 1, but you know what? There is a loophole. You technically can factor x squared plus 1. So look, I could factor x squared minus 9 because this is a perfect square, this is a perfect square, and this is a minus in the middle, right? What I have here is x squared plus 1. The predicament is that there is a plus in the middle, okay? However, I could change that. So instead of x squared plus 1, could I maybe write the plus 1 as minus minus 1? Could I do that? Why not? Of course I can. So now, when I had something like this, how would I factor that? I basically take the square root of the first one, x, x, the square root of the second one, 3, 3. Okay? So here, what I'm going to do is, I'm going to take the square root of the first one, x, x. Now I'm going to take the square root of the second one. And I have a minus in the first and a plus in the second. Now, what's the square root of minus 1? I. So this is I, and this is x plus I. So basically what I just did is I factored this with imaginary numbers. Now, kx, then the entire kx is x plus 2, x plus 3, x minus 4, x minus I, x plus I. No.
Oh, wait.
Okay?
I spelled it wrong.
So here we have a product of linear factors. Okay? Next, list all the zeros. Basically, we're going to set each one of these equal to 0 and get the value. So I have x equals negative 2, x equals negative 3, x equals negative 4, x equals positive I, and negative I, positive 4. Okay, in short, you can write negative 2, negative 3, 4, plus or minus I. That's totally fine. Now, how many zeros are in this box? 5. 1, 2, 3, 4, 5 zeros. And how many were we supposed to have? 5, because it's x, right? Total of 5 zeros. That's how we started this whole thing. Okay? So this is it. We just, well, you just factored your very first equation that has complex zeros. And look, who would have thought, right? That you could just take any equation, x to the 5 plus x to the 4. Look at this mess. Who would have thought that without even touching a graphing calculator, you would be able to get all 5 zeros, including imaginary. And guess what? The graphing calculator wouldn't even give you the imaginary zeros. Okay? So this is it. This is now, you know, the big deal about this lesson. Okay? All right. What we're going to do now is go backwards. All right? It's fine. You can get, you have the equation and you can find the zeros. Well, what if we switch things up? And I gave you these 5 zeros and I said, get me the equation kx. All right? That's what we're going to do now. So in this next problem, it says write a polynomial function of least degree with real coefficients in standard form that has, I believe this should be negative 1. This negative should be, is it on the,
negative 1.
right. So this is negative 1, 2, and 2 minus I as zeros. Now, imaginary numbers always come in pairs. So, if you're given 2 minus I, then you yourself have to add the complex conjugate 2 plus I. You will never be given both of them in the pair. You're always going to be given one, and you need to know to add in the second one. So, how many total zeros are there now? How many total zeros? 4. 2 plus I, 2 minus I, 2 negative 1. That means we're going to have a degree of 4. Okay, so it's going to be x to the 4 something something. All right. To go from the factors to the equation, to go from the zeros to the factors, we say x plus 1, all right, always the opposite sign, x minus 2. Here, x minus 2 minus I, x minus 2 plus I. Okay? So it's x minus the first 0, x minus the second 0, x minus this 0, x minus the other 0. Always minus, because it's always going to switch sign when you solve. Now, let me distribute the negative here and here. So the first two factors don't change. But here I get x minus 2 plus I, x minus 2 minus I. Now, x plus 1, x minus 2, x minus 2 plus I, and so on. Now, we always learn the associative property as, you know, the list of properties in algebra, but we never get to use it. Guess what? This is a chance where we get to use the associative property. What does the associative property say? Basically, it says here, you can group these in any way you like. So, whereas before the parenthesis was around the 2 and the I, you know what? Now I'm going to be a rebel and I'm going to put the parenthesis around the x minus 2 and the x minus 2. Okay? So I just grouped identical terms. Okay? Why? Because I can do that. Now, let's multiply this part. It's just basic foiling. So I get x squared minus 2x minus 2, x squared minus 1x minus 2. Now here, okay, why did I group them the way I did? It wasn't just for fun. It's because now I've created something. I've created something plus I, something minus I. So it's just like if I had x plus 3, x minus 3. What would I do here? If I had x plus 3, x minus 3, to multiply this, I would square the first one, I would square the last one, and put a minus in the middle. And we're going to do the same thing now. So I'm going to square the first one. I'm going to square the last one. And I'm going to put a minus in the middle. So when we go home tonight, we're all going to be watching this one more time. All right, now I'm just going to ignore this one for a minute. It's like the middle child that's going to get ignored for a little bit. This one, let's square the red one, okay? I'll keep the color coding. When you square it, we're now in pre-calc. We do this very quickly, and we get what? X squared minus 4x plus 4 minus, what's I squared? Negative 1. So in the end, it'll be plus 1. So at the end of the day, I have x squared minus x minus 2, still ignoring, x squared minus 4 plus 5. Do we all agree? Yeah. Minus 4x plus 5. Now, we're going to multiply this. Okay? So, what we do, again, I'll color code. So, first I'm going to multiply x squared with everything in the second parenthesis. So, I get x to the 4 minus 4x cubed plus 5x squared. Then I'm going to multiply negative x with everything in the parenthesis. So I get negative x cubed plus 4x squared minus 5x. Then I'm going to multiply negative 2 with everything. And now I get to combine like terms and put it in standard form. What does it mean to put it in standard form? Decreasing order of exponents. So x to the 4 has no partner. 4x cubed minus 4x cubed minus x cubed, negative 5x cubed, 5x squared minus 2x squared is 3x squared. Oh, plus 4x squared, so 7x squared. That's tricky. Minus 5x plus 8x is 3x, and that negative 10 is alone. There we go. This is your polynomial. So, plus 5 plus 4 minus 2. Oh, negative 5 plus 8 is 3. Right, this is what you do on the test. Now, the whole thing with the squaring the 2 minus I, the 2 plus I, right now it's very uncomfortable because it's fuzzy. So you watch this again and you do it a couple times. This problem, okay? So just take this part, write it down, and do it a couple times, okay? And then do it with another number. Do it with, x plus 4 plus I, x plus 4 minus I. Do it a couple times until you can do it mechanically, okay? Nobody knows how to do this the first time. Nobody is born doing it, and nobody gets it by doing it once, okay? I had to do it countless times in order to learn it when I was in high school. Okay. So, one last problem. You can find the zeros of a polynomial when one of them is known. Okay? It is possible to use synthetic substitution with complex numbers in the same way as with real numbers. All right, so here we want to find all the complex zeros given that 2 plus 5i is a 0. So now I'm given an imaginary 0. How do I find the rest? Okay? Right. But I need, okay, so how many total zeros does this have? 4. One of them is 2 plus 5i. That means another one is 2 minus 5i. But I still have 2 more. Those other 2 are either both imaginary or they're both real. And they could be rational, irrational, positive, negative, whatever. Okay. So what we do is synthetic division with 2 plus 5i. So I have 2 plus 5i here. And here I'm going to put down the coefficients of my function. Just a little, life hack when you're doing this. When you're multiplying with imaginary complex numbers, leave some room horizontally between the coefficients because it's going to get messy. So 1, negative 6, positive 35, negative 50, negative 58. Okay, and the rest just sort of requires patience. Okay, you turn off the cell phones, you're not talking or chatting with your friends or your boyfriends or your girlfriend or whatever, and you're just concentrating on this. Okay, so 1 comes down, you multiply everything by 2 plus 5i. Now when you add, you get negative 6 plus 2 is negative 4 plus 5i. Now, I'm going to multiply negative 4 plus 5i with 2 plus 5i. So I'm going to FOIL negative 8 minus 20i plus 10i plus 5i squared. 25i squared. So I have negative 8 minus 25 here, which is negative 33 minus 10i. And that goes here. When I add, I get 2 minus 10i. And now I'm going to multiply that with 2 plus 5i. When I multiply, I get 4 plus 10i minus 20i minus 50i squared. The minus 50i squared turns into positive 50. So that means I have 54 minus 10i. I go back there. When I add, I get positive 4 minus 10i, and I multiply. When I multiply, I'm going to get 8 plus 20i minus 20i, negative 50i squared, right? So what happens to the i's? They go away, and I get 58, okay? And you know that that's supposed to happen because it was a factor. Woohoo!
What does that tell you?
Nothing. That they were not lying to us.
Okay, so
Now I continue. Now I continue with 2 minus 5i. All right, so,
yeah, why would you?
because you need to get the other zeros.
How does that?
Watch. You don't have faith in the system.
Can we use the first?
One first and the second
I
one
don't have faith
second.
in my ability to
No,
do
can we
this.
use like the 1 minus 4 plus 5?
That's what we're going to do. That's what you have to do. So, 2 minus 5i. Now we're going to use the coefficients that we got. 1, negative 4 plus 5i. 2 minus 10i. 4 minus 10i. And when we're doing this step, something truly magical happens. This is what we're doing. Watch. Okay. 1 comes down. You have 2 minus 5i. What do you have left? No 5i because it goes away. So we get negative 2. You multiply with this. What do you get? Negative 4 plus 10i. What happens to the 10i's? Goes away. You get negative 2. You multiply. Negative 4 plus 10i. What do you get? 0 remainder. Now, you cannot tell me that this is not just pure satisfaction. Okay. So from here I get, all right, so what are the, okay, so let's do this whole thing now. So we had x minus 2 plus 5i, x minus 2 minus 5i, and here I have x squared minus 2x minus 2. Okay? Now, these are the factors. This one, though, you know, it needs to be, the negative needs to be distributed. So it's x minus 2 minus 5i, x minus 2 plus 5i, and x squared minus 2x minus 2. Now, these are the factors, and I have an irreducible quadratic factor in there. Can you factor this? X squared minus 2x minus 2? It can't be factored. So how are you going to find the zeros?
You guys tell us.
Quadratic formula.
With just the middle one, right?
With just this one.
Okay.
So x equals 2 plus or minus the square root of b squared minus 4 times a times c over 2a. That means we have 2 plus or minus, what is this? 4 plus 8 is the square root of 12 over 2, which means this is 2 plus or minus 2 root 3 over 2. The 2's cancel. 1 plus or minus root 3 is what we get from here. So the zeros are, because when you divide 2 by 2, you get 1 and 1. It doesn't cancel completely. So the zeros are 2 plus 5i, 2 minus 5i, 1 plus or minus root 3. As promised, 4 zeros. And that's your answer. Huh? It's magical. Now, I have one more thing to say. Now, this problem asked you for the zeros. Had it asked you for the linear factors, which it might, had it asked you for the linear factors, then it would have been x minus 2 minus 5i, x minus 2 plus 5i from here, and also x minus 1 minus root 3, x minus 1 plus root 3. Okay, you put in all the zeros. And that's your answer after you simplify the negatives. So, x minus 2 minus 5i, x minus 2 plus 5i, x minus 1 plus root 3, x minus 1 minus root 3. So this would be all the linear factors. So the big deal is, however many zeros, whatever the degree is, that's how many zeros, that's how many linear factors, okay? And remember that the zeros are where what happens? The graph does what? Crosses the x-axis.